I'm Anil Kumar. Welcome to my series on trigonometric ratios. We are going to understand a few critical issues while solving this beautiful question. Let me thank my student Bela for posting this. I hope many students will benefit from its solution. Solve for theta to the nearest degree where theta is between 0 and 360 degrees. So we'll actually solve three different equations. Cos 2 theta equals to 0.6420, sin theta plus 20 degrees equals to 0.2045, and tan of 90 degrees minus 2 theta equals to 1.6443. Well, some of you can always pause the video, answer the question, and then look into my suggestions. The critical part here is that theta is given to us as between two limits. The limits in this case are from 0 degrees to 360 degrees. That means all possible solutions within this interval for theta. Now if I want to solve the very first question, which is cos 2 theta equals to 0.6420, then I have to find the limit for 2 theta, right? So if theta is between 0 to 360, then 2 times this value should be what? Well, in that case, we have to multiply the interval by 2. So I get 0 degrees as a lower limit and 720 degrees as the upper limit. So this is always the first part. Even in part B and C, you have to do something like this before even starting your solution. I hope that point is well taken care of. Now, let's get back to part A of this question, which is cos 2 theta equals to 0.6420. So we're looking for a positive value of theta, right? So when I say a positive value, I'm expecting two solutions, right? One in quadrant 1 and one in quadrant 4. In both these quadrants, cos is positive, right? So you know the rule. All are positive in quadrant 1, sine in 2, tan in 3, and cosine in 4. So a positive value here means we are looking for solutions in quadrant 1 and in quadrant 4. Correct? So step number 1 is find the acute angle alpha, right? So we'll find the acute angle alpha. We'll say let cos alpha be equal to 0.6420. So from here, what do we get alpha as? Alpha as equals to cos inverse of 0.6420. So in degrees, let's figure this out. So we get shift cos inverse 0.6420 is equal to 50.05. Correct. So we get an angle of around 50 degrees. We say alpha is approximately equal to 50 degrees. Now we know one angle alpha. Now this is between 0 to 90. We want all possible angles from 0 to 720. Do you see that? Now since cos is also positive in quadrant 4, this angle also is our solution. And we are interested in angles from 0 to 720, and therefore I will write this angle as what? This is also alpha, right? But I'll write this as 360 minus alpha. So the other angle which will be giving us the same value will be 360 degrees minus 50 degrees. Do you see that? Now that gives us a value which is much lesser than 720. That means I can go one more circle. So whenever there is 2 theta, that means we are going 2 rounds. Do you see that part? So we are going 2 circles. So we can add 360 and 360 to these angles to get more angles. So 360 minus 50 is 310 degrees. So we get these two possible values for, let's say, angle alpha, right? We'll figure out theta later, which is 2 theta, correct? Now if I add 360, I get what? 50 degrees plus 360 degrees, which is 410 degrees, and also 310 degrees plus 360 degrees, that gives us 670 degrees. Now all these angles are equal to what? They're actually equal to 2 theta, right? So we're talking about cos 2 theta. So 2 theta is equal to 50 degrees, is equals to 310 degrees, is 410 degrees, or 670 degrees. You get the idea, right? So what is theta? Theta is half of these angles. So theta is equal to 50 degrees divided by 2, 310 degrees divided by 2, or 410 degrees divided by 2, or 670 degrees divided by 2, which gives you the answer as 25 degrees, half of this, right? So which is 1, 5 degrees, 205 degrees, and half of 670, 3 gives you 6, and then 3 times 10, 5, 335 degrees. Correct? So these are the 4 solutions for part A. Do you see that? So when we are talking about cos 2 theta in the interval where theta is between 0 to 360 degrees, we expect 4 solutions as shown here. So I hope the steps are well taken care of. Now we will do part B and C. Now let us solve the equation sine theta plus 20 degrees equals to 0.2045, where theta is between 0 and 360 degrees, right? We need to solve for sine of theta plus 20 degrees. Now if theta is between 0 to 360 degrees, what should be the value for theta plus 20? So we will add 20 to this. So we get theta plus 20 degrees should be between what limits? Adding 20 to both the ends, we get between 20 degrees to 380 degrees. Does it make sense? Right? So that is the first step, to look into the domain, right? Now, we know this should be equal to 0.2045, right? Where theta plus 20 now should be between 20 to 380 degrees. Correct? Now, positive value for sine is in quadrant 1 and in quadrant 2, correct? Using the rule that all are positive in quadrant 1, sine in 2, tan in 3, and cosine in 4. So we are looking for 2 solutions. One in quadrant 1, the other one is in quadrant 2, right? So let's again find the acute angle alpha. We always begin with alpha and then we'll adjust, right? So we can say sine of alpha should be equal to 0.2045. So what should alpha be? Alpha should be sine inverse of 0.2045. Correct? So we have shift sine inverse of 0.2045 equals to, it gives us 11.8 degrees. Now 11.8 is not in our domain. Do you see that? 11.8 is not in our domain. So that is one answer. And what is the other answer? So this is one. The other angle is this one, which we get with 180 minus 11 degrees. So one we get as 11.8 degrees. The other one is 180 degrees minus 11.8 degrees. How much is that? Let's calculate. 180 minus 11.8. In decimals, it is 168.2. Now that is in our domain, right? Between 20 degrees to this. Now what should we do? Now since sine is a periodic function, right? It's a periodic function. So if 11.8 is not there, we can add 360 to this, right? So the option could be 360 degrees plus 11.8. How much do we get? We get 380 71.8 degrees. Correct? That is in our domain. Correct? So what we get here is that the angle alpha could be either 168.2 degrees or alpha equals to 371.8 degrees. I hope that point is well taken care of. Now what is this angle alpha we're talking about? It is indeed theta plus 20. So let's replace this with theta plus 20 degrees equals to 168.2 degrees, and so we get theta equals to 168.2 minus 20, and that gives you the first answer, which is 148.2, and rounding to whole numbers, 148 degrees. Perfect. The other answer we can get from 371.8. So we know theta plus 20 degrees is equals to 371.8 degrees. So theta is equals to 371.8 minus 20, right? So that gives us 351.8 or 352 degrees rounded to a whole number. Correct? So these are the two solutions for the given situation. Correct? So our answer is theta equals to 148 degrees and 352 degrees. As you can see, both these angles are within our domain. You get the idea. So we have to make some adjustments to our final answers whenever we're looking for answers in a specified domain. So that is a very critical issue which should be understood, and that is why we are solving these questions, right? Now let's take up the last question. Now here is part C. I hope you got the concept. I'd like you to pause the video, answer this question, and then look into my suggestions. We need to solve for tan of 90 degrees minus 2 theta equals to 1.6443, where we are given theta as between 0 degrees to 360 degrees, correct? Now remember, we are looking for 90 degrees minus 2 theta. So we have to change this domain. So to change it, we can multiply by 2 first. So we get 0 degrees less than equals to 2 theta less than equals to 720 degrees. We need minus. So minus 0 is kind of 0. But when you multiply by minus, the inequality signs change. This is a very important step, right? Now we have to add 90 degrees. So we'll add 90 degrees. So you get 90 minus 2 theta. And when you add, you get minus 630 degrees. So that becomes your modified domain for this thing, right? So we can write this as, let's say, tan of alpha equals to 1.6443. Now when I say tan alpha is positive, then what are we looking for? Well, we are looking for two solutions, and these are in quadrant 1 and in quadrant 3. Since in these two quadrants tan is positive, correct? You know the rule, all are positive here, sine, tan and cos, correct? Now we also know that this angle here is 180 degrees. Tan has a time period of, so tan theta has time period of 180 degrees. So even if we get one angle alpha, we can add or subtract 180 degrees to get all other solutions. Perfect. So within a particular domain, we expect 4 solutions. Correct? For 2 theta, because it is 2 theta, right? So we expect 4 solutions, 2 in 360 degrees and 2 more in the next circle. Perfect. So as we did, we'll first find the acute angle alpha, which is tan inverse of 1.6443. So tan inverse of 1.6443 is equal to 58.69, let's say 7 degrees. Okay. So that becomes one solution. But we know we are looking for something which is between minus 630 and 90 degrees. 58.7 is what we get. So to get the other solutions, what can we do? To get the other solutions, we can take away 180, right? So the possible values of alpha could be 58.7 and the other values could be take away minus 180, right? So 58.7 minus 180 degrees, which is how much? So let's keep on subtracting 180. 58.7 minus 180 is equal to, within decimals, 121 negative sign 0.3. Then from minus 121.3, let's take away 180 degrees. How much do you get? So minus 180 gives us in decimals minus 301.3. Now from minus 301.3, we'll again take away 180 degrees, minus 180, and that gives us in decimals minus 481.3 degrees. Do you see that? So we got 4 solutions, correct? Now if I again take away 180 from here, I get 661. So if I do minus 481.3, take away 180 degrees, I get minus 661.3 degrees, right? These are all in degrees. Clearly, 631 is our limit, right? So this is not a part of our solution, correct? So this will cross out. But these 3, rather 4, are part of our solution, correct? So these are the values of alpha, which is 90 degrees minus 2 theta. You get the idea, right? So 90 minus 2 theta is 58.7. And from here, you can find what theta is. That's the whole issue, correct? So now we can solve for theta. So what we get here is 58.27 is equal to 90 minus 2 theta, right? So to get the value of theta, what should we do? We have to take away from 90 58.7 and then divide by 2. So we get that theta equals to 90 minus 58.7 divided by 2. That is what we get. So let's calculate this. So we have 90 minus 58.7 equals to, divided by 2 equals to, which is 15.65 degrees. Rounding to 16 degrees. Do you see that part? So that is how we are going to calculate our answers. Correct? Do you see the idea? So we get different values of theta from these values. So let's calculate all others. That was positive, right? 58, these are negative, so they will get added to 90. So the other angle of theta will be 90 plus 121.3 divided by 2. So this is for the second value I'm calculating. Do you see that part? So there's limited space, so I'm just writing it. So we have 90 plus 121.3 equals to, divided by 2 equals to, in decimals, 105.6, which is approximately 106 degrees to 1 decimal place. Now the third angle we could get by 90 plus 301.3 divided by 2, correct? So we'll do 90 plus 301.3 equals to, divided by 2 equals to, converting to decimals, we get this as equal to 195.6 or 196 degrees. Do you see that? So that is how we are going to do it. Let me show you the calculations in details for the last one, right? So what we get here is, I'll redo, right? So 90 degrees minus 2 theta equals to minus 481.3. So let's rearrange. So we get 90 degrees plus 481.3 equals to 2 theta. Is it okay? Now what is theta equals to? To get the value of theta, we'll divide by 2 on both these sides. Correct? So we get theta. So that is how we are doing all these calculations. So let's calculate this answer. 90 plus 481.3 equals to, divided by 2 equals to, and now we are going to round this 285.6 rounded to 286 degrees. You see, all the angles we have got are within 0 to 360 degrees, correct? So our solutions are 16 degrees, and then we get 106 degree, 196 degree, and we get 286 degrees. Perfect. So that is how we are going to solve it. Now for tan 2 theta, the period is going to be 90 degrees, right? So if you add 90 degrees to each, you get your solution, right? So that's another way of doing it. Anyway, you have seen in details how do we solve such trigonometric equations by adjusting the domain of the function. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great. Thanks for watching and all the best.